All right, guys, so we are going to go over section 1.7, and I have the notes there in the bottom corner, and I may take them away as we go, but refer back to them at other times. But we have some notes there, and I'm not going to read those to you, numbers 1 through 5, but essentially those are properties of inequalities. Okay, so we have now moved from solving equations to solving inequalities, and we will go over all of that as we work through these examples here. So we're going to jump in, and I'm going to scroll up. These are your lecture notes online, so pause, stop. If you don't have these, go print these off and come back and you can work through these with me. Okay, so example 1 is asking us, and you can read that, to solve the inequality, graph the solution set, and write the solution in set builder notation. So it gives us 3 times x plus 4 is greater than 5x minus 8. So let's see if I can, there we go, that goes away. So guys, we're going to solve this much like we do with a equation. We want to isolate that variable. I want to get that variable on one side and all of my numbers, the constants, all of that jazz on the other side. So before I can do any of that, I need to distribute that 3 there. That will give me 3x plus 12 is greater than 5x minus 8. Now, what I would do at this point is move that 5x to the left-hand side of that inequality. And we would do one step at a time here. This will leave me with a negative 2x plus 12 is greater than a negative 8. All right, so again, I want to take that number there, that 12, and move it over there where that negative 8 is, and I will do that by subtracting 12. And that will give me a negative 2x is greater than a negative 8 minus 12 is going to give me a negative 20. And my last step here to isolate that variable, guys, is to divide by negative 2. Now, here's a note that I want to add to the side of my paper. Note that when we divide or multiply by a negative, the sign flips. Okay, so what does that mean? I kind of shortened that a bit, but what that means is when you divide or multiply by a negative number, which is what I have written there, and that's what I did, I divided by negative 2, the sign of the inequality is going to change. So 20, a negative 20 divided by negative 2, that gives me a positive 10. So this is telling me that all numbers less than 10 is part of my solution set. Okay, so if I go back to my problem there, so it was asking me to write in set notation, set builder, write this, let's see, graph the solution set, write the solution in set builder notation and interval notation. So my set notation would be my solution is the set of all real numbers x such that x is less than 10. Okay, interval notation, how do I represent all numbers less than 10? Well, it's everything from negative infinity to 10, but because I don't have the equal sign there, I'm not actually including 10, I am going to put parentheses there, showing that's where I'm stopping. And then if I were to graph this, you could put maybe 10, 11, 9, 8. So if I were to graph that, I would graph this with a parentheses at 10 and show that I'm going to graph all numbers less than 10, all numbers less than 10 as part of my solution set. So that is your answer for number 1. on your notes.